So we just wanted to take a moment and kind of explain a little bit of the difference between Future Technologies Initiative, FTI, which I chair, and the symposium, which we're attending today, the event, and also to talk about kind of where we're headed with some of these things. And then we'll jump back into the program. And we also have a big announcement to make.
So Alan, probably you can start from explaining what is FTI.
Okay, so I think it's useful to talk a little bit of the history to understand it. So my personal background is I worked in the space industry. I was at NASA for the majority of my career before I joined Facebook, now Meta. And the first time that I came to OCP, it was big, it was inspiring, it was really interesting. But what I was used to from the space industry was when we had an industry kind of gathering like this, there was dedicated time towards researchers and towards startups and towards academics. A few different benefits that I saw from that community with the small satellite programs I was involved in. One is you pointed the academic research and the future technologies of what was coming down the pike and the opportunities and risks. So we were able to get that in front of the industry. And then the second was kind of recruiting, just to start to bring people into the industry at an earlier age and start to surround them with opportunity and awareness and contacts and networking within the industry. So my first couple of years I was observing, and I think in 2018 I went to the leadership in OCP and just said, hey, I'm used to seeing something like this, like I'd call it a symposium. Why don't we have anything like this? And they said, great, go create that. And that was January of 2018, I believe. And you know, we used to do the global events in March. So I had about 8 weeks to pull together. I think we did 14 papers that first year. So we started out as symposiums. We started out as ride-along events to these global summits and regional summits we were doing in Amsterdam at the time in EMEA. And then we started to actually build a community of collaborative R&D. So the OCP, we started to, Brennan, you're going to hear the exact same thing you heard yesterday. Sorry. At the end of 2020, the OCP leadership and the incubation committee said, hey, we have these opportunities for collaboration, but some of the things are actually longer term R&D, 2, 3, 5 years plus. So could the FTI take them on? Could we establish a broader umbrella than just the symposium events? And thus, Future Technologies Initiative was created. These are 3 work streams. You've heard from all of them. There'll be some breakout sessions the afternoon on this level. But that's kind of how we got to where we're at. So you can think of FTI as all the effort where we actually take the opportunities provided, like George said earlier, just by individual papers or ideas or topics, and those things spinning into work streams that actually would affect the industry. So a couple of the papers I'll call you to, especially in the networking realm that James is going to run, we've been discussing during this event a new work stream next year around optical interconnect architectures. And so there's some very fascinating technologies being presented today by LED optical interconnects over very short distances like 10 meters. But guess what? You don't need 10 meters to interconnect between racks in an AI system. So some of these technologies are starting to be ready, and they're coming out of symposium to be ready for long-term work streams where we'll eventually align with the industry. So that's kind of the language that we have for Future Technologies Initiative, and then now Lesia will talk about symposium in the context of FTI.
Yeah, so the mission of the symposium is to identify the promising future technologies, bring them to you, submit your papers, and create an exposure for these people from the research, from the industry and startups. So I'd like to share some of the stats that we had, some of the results for this year. We received 60 submissions. This is a good result. Thank you for sending your papers. We have 16 posters and presentations and 11 posters only. So this very, very good starts for us. And in terms of the diversity, we have industry. We have people from the academia startups. So thank you so much for applying and sending your future technologies to the symposium. Again, the posters are available here, and they will be also available tomorrow in the concourse lobby. I wanted just to take a couple of minutes to thank our program committee. So you already met Nicole. You will see James, CMAC, and Manish, unfortunately, was not able to do that, to be here with us today. But these are the people who help us to reach out to different people from the industry, startups, and academia. And they help us to create the content, select the best papers, select the submissions, assess the submissions. And I would like to thank James. You did a really great job this year. Was a really pleasure to work with you. Also, I would like to tell a special thanks to all those people who help us to analyze and assess papers. It's not only our program committee who does the work, but we also rely on different experts. So thank you for all your contribution and for your help. We also have the Best Paper Award. For each of the technology track, we will announce the best paper per technology track, as well as for the Future Technology Symposium. And we would like to invite you to this announcement session tomorrow that will be at Expo Hall at 12:30. Please join and celebrate innovations with us. And a couple of words regarding the Future Technology Symposium that will take place in Europe, in Prague. So on April 18, 2023, this is the EMEA-focused event. We are going to make a curated content on data center sustainability and AI. So if you have proposals, if you have some great projects, future technologies, come and talk to us today and find out how can you get involved. And you can also sign up to our group on LinkedIn to stay informed about all the news that come in from FTS and FTI.
And we already talked about there's a bunch of work streams that are in the works. So we're talking quantum as possibly like a 10-year collaboration thing, optical interconnect. We're always looking at sustainability technologies like heat reuse. So we will continue to do that. And then really, I guess the note I'd like to land on before we call up Yang to make a big announcement about the new work stream around computational storage is we've really done this in a silo. We've been really privileged to just kind of be off on the side, no one really noticing us, building a community, but we were a little bit separate from the industry membership of OCP. The next phase of our impact really relies on the OCP membership. So people getting involved, specifically use cases that are saying, hey, this is actually the use cases that we could see for optical interconnect. Here's how we're thinking of approaching quantum computing and interfacing to our classical computing and acceleration architectures of today. That's how we're going to provide usefulness, is when you come and join us, you participate in the symposium events, you join FTI work streams, you engage with us and point us and raise awareness of opportunities that we need to be pursuing for you. Okay. And our big announcement is that we are standing up, we are announcing today that we're standing up a computational storage work stream in 2023. So Yang Ki, our tech chair for the working group, is going to come up and present on computational storage.
Thank you, Alan, for introduction. Hi, good morning. I'm Yang Seok-ki, Vice President of Memory Solution Lab at Samsung. Today, I'm going to talk about the new work stream launched this year. Especially, I'd like to thank Alan again, because actually the going through this kind of process is not kind of new to me. It's new to me, so that he helped me to go through the process and eventually launch a new work stream like this today. So what is computational storage? You actually heard about that in the morning, but the precise computational storage, why we actually need to think about this kind of new approach. So as data grows, actually we have to handle the data more efficiently. So we have to actually switch our thought process, how to process data more efficiently. So compared to the traditional von Neumann architecture, I believe the data-centric computing is more important, and we have to actually come up with new solutions to solve the problem more efficiently. So yesterday, there are a lot of keynotes talk about the sustainability, power efficiency, and how to overcome the network bandwidth problem and the memory bandwidth problem. And according to the science paper published 2020, more than 50% of power consumption in the data center actually due to the server power consumptions. So there are many ways to address this problem. As Ampere mentioned yesterday, you can have a new CPU which consumes less power. And Meta also mentioned about the domain-specific architecture and the accelerator in different domains. So there are many approaches. And we heard about IPU and the DPU, many different type of accelerator. But how about the storage side? Storage size and memory side, mostly passive entity didn't do anything actually well and mostly rely on the CPU. But as data grows, actually, if you handle data more efficiently near actually where the data is stored, we may be able to do the better job. So at the long term, what I envision is, okay, so instead of doing everything in the CPU, we have a lot of accelerator, DPU, IPU, and even computational storage. Depending on the data locality and energy efficiency, we can determine where the data should be processed. So on the right side, actually, the data can be classified into 3 categories: data at rest, data in transit, and data in use. So depending on the power efficiency and the data movement kind of cost, we can determine where data should be processed. So instead of doing everything in one place, leveraging the capability of different accelerators, we can determine where data should be processed. That's kind of the long-term vision, and I believe computational storage can be a key cornerstone for enabling this kind of technology. By doing that, we may be able to reduce overall power consumption and energy consumption in the data center significantly. As Sung mentioned in the morning, in the keynote, actually the computational storage can reduce power consumption significantly if the application can leverage that computational storage devices. And the NPU and the IDP also claim similar thing. Let's connect them together. But in the short term, actually, then narrowing the scope in this work stream, we're mostly focusing on the computational storage and how we can help to enable that technology in the OCP FTS FTI. So what is computational storage? Simply put, we can say early data transformation using the near data processing. So instead of moving data around, process data where the data is actually reside. So in this diagram on the left, so that's concept of computational storage. Traditional system read data from the disk into DRAM and load the data into CPU cache and process and store the data into DRAM again, probably store the data into storage as well. So this is a very long journey of the data and consume a lot of power, especially considering the situation, CPU, the traditional x86 consume more than 300 watts. It's kind of the waste of the power and energy if you are doing a very simple operation. Instead of doing all the operation in CPU, if the device can handle that workload efficiently, why don't we use the computing capability inside device and process data inside device? By doing that, we can use low power processing unit and also reduce the amount of data moved transfer around the system. By doing that, actually, we can save power and energy significantly. So, okay, I got it. Then what this workstream is going to do. So this is not just device problem, it's actually system problem. So we have to handle many different type of layers to address this problem properly. So we'd like to cover from the actual device side. That's okay. We can have a kind of vendor-neutral development board and develop the various applications and see whether certain application can be used for computational storage or not. But in the standard body, actually, we have 2 standard body working on computational storage, one of the NVMe, and working on how to define the commands and the logic of using the storage device as a computing unit. And the SNIA side, they are defining some computer storage API and the library architecture to use this device more efficiently. But the missing pieces in the industry is that how we can actually use this device seamlessly across different applications. So this work stream going to focusing on the hardware abstraction and the program model. And we also need the benchmark and the reference system prove this architecture. So we heard about the memory, near memory processing in the SDM and the AI hardware co-design work stream. So there are some area we actually work together to make this concept more effectively and deploy to the industry with high impact. So currently the work stream has 4 members, the Samsung, the AMD, and the Hynix. And actually Hynix confirmed to join this work stream. And we work with the Microsoft to make this work stream more effective and fruitful. Because the work stream mostly gonna starting from top down. So meaning that we mostly focusing on the application, not the actual device itself. So please join this work stream if you're interested in this topic. And we're going to have a kickoff, the kind of conference call next Thursday. So you can reach out to me or reach out to Alan to get more information about this work stream. Thank you.
Thank you so much, Jan. Unfortunately, we do not have time for questions. So if you're interested to join, please reach out to Jan, to Alan, to myself, or sign up for the meeting on the October 27th.